Good morning, children. Today let us start with group 16. Yesterday we have completely done group 15. Have you revised that? Are you facing any problem in group 15? Okay. Now let us start with group 16. Group 16 elements are otherwise termed as chalcogens. Chalcogens means ore producing elements. Is it clear? Group 16 elements are termed as chalcogens. Chalcogens means ore producing elements. Ore we have already studied, that is the mineral from which the metal can be extracted easily and profitably is termed as ore, and ore producing elements are collectively termed as chalcogens. Or this group is also termed as oxygen family. It is also termed as oxygen family since oxygen is the first member in the group. Okay, children. Now let us consider the sources of this group of elements. Oxygen, you know that it is the most important component in air. As well as if you just consider the earth crust, around 46.8% of earth crust by mass we can see the presence of oxygen. And the second element, if you consider sulfur. Sulfur generally exists as sulfates like gypsum. You can see gypsum in the form of sulfate, or you can see Epsom salt. Epsom salt, or we can see barite. Okay, that is in the form of sulfate, you can see sulfur in these three forms, that is gypsum, Epsom salt or barite. And in the form of sulfur, this is in the form of sulfates. And you can also see sulfur in the form of sulfides like galena, zinc blende or copper pyrites. Okay, you can see sulfur in the form of sulfides like galena, zinc blende and copper pyrites. And even you can see traces of sulfur in the form of hydrogen sulfide in volcanoes. You can see sulfur in the form of hydrogen sulfide in volcanoes. In addition to this, sulfur is present in small quantity in organic molecules like hair, protein, that is garlic, onion, mustard, wool, silk, etc. In all, these all are sources of sulfur. Sulfur can be present in the form of sulfates, sulfides, as well as you can see it in the form of hydrogen sulfide or even in organic molecules. And then if you consider the metals like selenium and tellurium can be present as metal selenides and tellurides. Okay, and polonium, the last element in the group, it is a radioactive metal, so it is generally produced as a radioactive, decay product of thorium and uranium. Is it clear, children? Have you got some idea about the sources of different elements of group 16? Okay, now let us consider the elements. The elements are oxygen, sulfur, selenium, tellurium and polonium. If you consider the elements are oxygen, sulfur, selenium, tellurium and polonium are the members of group 16. If you consider their atomic numbers, that is 8, 16, 34, 52 and 84. And the electronic configuration we can write it in terms of inert gases. Even in 15th group we have studied it in terms of inert gases. So here also we can consider it in terms of inert gases. Oxygen, helium core 2s2 2p4, sulfur, neon core 3s2 3p4, selenium, argon core 3d10 4s2 4p4, tellurium, krypton core 4d10 5s2 5p4. Or if you consider polonium, the last element in the group, xenon core 4f14 5d10 6s2 6p4. That is about the electronic configuration of group 16 elements. Is it clear? We have written the electronic configuration in terms of inert gases, and you can see that in the first element there is no d orbital since it is completing in second shell where d orbital is not present. And in the third element selenium you can see the presence of D completely filled d orbital, and in the last element polonium you can see the presence of completely filled f orbital. Is it clear, children? Now let us study about the general properties of group 16 elements. If you consider the general properties as we have already studied in group 15, the first property is electronic configuration. We have already seen the electronic configuration. So can you tell me what is the general electronic configuration? Yes, it is Ns2 Np4 is the general electronic configuration of group 16. Now second one, let us consider atomic size, atomic and ionic size. Atomic and ionic size. That is, when you are seeing the electronic configuration, you must have observed one thing, that as we move down the group, number of shells increases. So obviously atomic or ionic size increases. Is it clear, children? As we move down the group, atomic size increases due to the increase in the number of shells. Now third property, let us consider ionization enthalpy. Here, as we have discussed in case of group 15 also, we can say that as we move down, since the number of shells increases, the atomic size increases, obviously the energy needed to remove the electron decreases or ionization enthalpy decreases. Now in this case, one question can always be asked, why group 16 possesses less ionization enthalpy than group 15? Can you tell me why? Yes, it is due to half-filled configuration of group 15. Group 15 elements possesses a stable half-filled configuration of Ns2 Np3. Is it clear? Next one, let us consider electron gain enthalpy. That is, oxygen is the first element, and because of its compact nature, due to its very small size, inter-electronic repulsion is more in case of oxygen. So the electron gain enthalpy of oxygen is less negative compared to that of sulfur. This can also be asked in the form of a question. Why oxygen possesses less negative electron gain enthalpy than sulfur? Why? Due to compact nature of oxygen, inter-electronic repulsion is more. So the electron gain enthalpy of oxygen is less negative than that of sulfur. And then as we move down, electron gain enthalpy becomes less and less negative since metallic nature increases. Next, last general property, let us consider electronegativity. We can say that as we move down the group, atomic size increases, their metallic nature increases, so obviously electronegativity decreases. Is it clear, children? That is about the general properties of group 16 elements, and in next class we can discuss about the physical properties. Thank you.